In our next example, we want to analyze the equation x squared over 25 plus y squared over 9 equals 1. There's a couple things that we can recognize from this equation. Our a squared value is the bigger number, which in this case is the 25, and it appears under our x term. So we know that the x-axis is going to be our major axis, or the horizontal axis will be the major axis. We also know this ellipse is centered at the origin 0, 0 because you don't have any other numbers in here with your x and your y terms. We can also go ahead and start taking a look at our a, b, and c value of this equation. So a is going to be the square root of 25, or in this case 5. That's going to be our distance from the center out to one of our vertices. Your b value, which in our case is going to be the square root of 9, or 3, is going to be the distance from the center out to one of those points that appears on the minor axis. And c is going to represent our distance from the center out to one of the foci, and we're going to be using the equation c squared equals a squared minus b squared to get that. Think of it as we're going to be subtracting these two numbers and then taking the square root to get our c value. Our c value in this case is going to be a 4. So let's go ahead and start taking our information, and we can start plotting the pieces that we know. We know our center is at the origin, and we know our distance out to a vertex is 5 units. So I went ahead and plotted my V1 and V2. We also know our distance out to the foci is 4 units, so I plotted F1 and F2. Here's a summary of my points so far. Our center is at the origin, and since our vertices are 5 units out, we have V1 at the point -5, 0 and V2 at 5, 0. Our foci were 4 units out from the center, so the points -4, 0 and 4, 0. We also know that the distance to the points along the minor axis were 3 units out, so I'm counting 3 units up and down from my center. So I have the point 0, 3 and 0, -3. Here is a final sketch of our ellipse. Now let's also take some time to talk about what happens when your major axis is along your vertical axis or your y-axis. So let's talk about this equation. We've got x minus h, the quantity squared, over b squared, plus y minus k, the quantity squared, over a squared equals 1. And keep in mind that the criteria here with a and b is still the same as our last example. Our a value is bigger than b, and both of those values are something bigger than 0. So you're going to notice that your a squared term this time is underneath your y terms, which is the indicator that your y-axis or your vertical axis is going to be your major axis. All of the other pieces are going to stay the same. A is still going to represent your distance from the center out to a vertex. B is still going to represent your distance from the center out to a point that's on your minor axis, and C is still going to represent the distance from the center out to one of your foci. And obviously, if your center, the HK, is at the origin, then this is going to condense your formula down to x squared over b squared plus y squared over a squared equals 1, since your h and k values would both be 0.